So today we're going to talk about the concept of steady versus non-steady or transient flow. So again, we're continuing looking at flow processes, and let me just start out with an example of a cup. So if I have this cup, and what will happen if I just go ahead and I start pouring some water in here. So I got some water that I pour into the cup. Well, what's going to happen is that the cup's going to hit here in the bottom, and it's going to get higher and higher and higher and higher and higher, and eventually if I let the water just flow into the cup, it's going to overflow. This is an example of a non-steady or transient process because the height or the amount of water within the cup is changing with time. So depending on how long I've been putting the water into the cup, that will change change how the height or how much water is in the cup. Now let's just take this and look at how another process similar to this. What if I take my cup, but I put a little hole in it, just a little hole at the bottom, and I go ahead and try to fill it up again. I start to put water into it. Put water in. Well, what will happen is, we'll get some water here at the bottom, but I'll also have water coming out. So I'll have water going in and water going out of the system. And depending on how big my hole is and how much water I put in the system, it may be that all of the water will just flow right through the system. If there's a big hole, all the water just may come right out the bottom of the cup. If it's a really tiny hole, and I put in a lot of water, like I put it in under a faucet in the kitchen, and there's only a really small hole, what'll happen is that I'll still get some water accumulating within the cup, but I'll have a slow leak at the bottom of the cup. And that just again depends on the hole, how much is going in. Now what if I have the case where the amount coming in equals amount coming out? Well, if the amount coming in is equal to the amount going out, the height of the water, or the amount of water in the cup, will stay the same. It's because every time I put some water in, some of it would come out. And this process, where the amount going in is equal to the amount going out, is known as the steady state, or steady process. Steady state or steady process. And we are going to, in this course, we are going to deal with steady state processes probably 95% of the time. That's the most desirable case in a real operating chemical plant, and a large reason is it's easier to maintain, it's easier to manage, it's easier to take care of. If you always know that what's going into your system is coming out of your system, you have better control of it and so forth. It's also easier mathematically to understand and analyze the system. And that's the difference between steady state and non-steady state. When we have steady state, in is equal to out. Non-steady state, in does not equal the out. And that's the key concept you got to get built into your head. And you have to remember this over and over. For steady state process, in equals out. The amount of material going in is equal to the amount of material going out. So let's look at how we apply the concept of steady state to understanding material balances. So material balances is a big part of the course and what we're going to spend a lot of time doing. And material balances is just putting a balance on material. Hence the name material balances. So let's look at a simple process here. Let me draw a box. And we have some material A. We'll just call it material A going in. A could be anything. It could be water, it could be ethanol, it could be potassium chloride, whatever. It doesn't matter. We'll just call it A for now. Under steady state, A is coming in, A is coming out, and A in, A out, I'm just labeling those the subscripts, they're equal to each other. And so that's a simple process, and this is an equation that we call the material balance, where A in equals the amount material coming in. And A in, or A out for that matter, A in is just the amount of of coming in and A out is the amount coming out. It could be represented in terms of units of moles. It could be in terms of mass. So it might be kilograms, might be pounds, etc., etc. It doesn't matter. Under steady state conditions, the amount of moles or the amount of mass coming in is equal to the amount going out. And again, it could be in mass or moles. And we'll deal with both those in this course. But this equation right here, let me put a nice little box around it. This is our material balance equation under steady state conditions. And it's a mathematical equation that says the amount of material A going in is equal to out. So if I know that there's 5 kilograms of A coming in, I know there's 5 kilograms of A going out. So that the variable A in is equal to 5 kilograms, A out, 5 kilograms. Pretty straightforward on that. So it's a mathematical equation, again, that we use to use to analyze our system. Let's look at another example. So in this case, more complicated. In this system, we have only species A. That's our only component that we have coming in here. Again, it could be water, it could be ethanol. It doesn't matter. Just some chemical, some material. And I'm going to label this stream 1, label this stream 2, and label this stream 3. So I have 3 streams, 1, 2, and 3. And if I do a material balance, A1 plus A2 is equal to A3, again under steady state conditions. And this is our material balance for this particular process, which simply says that the amount of A coming in on stream 1, which is this stream, plus the amount of stream A coming in stream 2, this stream, is equal to the amount leaving, which is this stream. And this setup right here is simply just a mixer. I'm taking 2 streams and mixing them together to produce one final mixed stream there. Now, in this equation again, our material balance equation, and this is the type of equation that we'll use to solve our systems when we're trying to figure out flow rates of different components and when we start analyzing different chemical processes. One more example here, and this is the case where we have 2 components. Let's just do this here. And again, this is stream 1, stream 2, stream 3, and let's just say we have components A and B. So we have a mixture, we have 2 components coming in and 2 components going out. And A could be water, B could be sodium chloride, or for an example, or it could be other compounds. Well, if we write out the material balance, A1 plus A2 is equal to A3, B1 plus B2 is equal to B3. So this is just simply telling us, again, that the amount of A going into stream 1 plus the amount of stream A going in stream 2 is equal to the amount coming out of stream 3. And the same with B. Amount of B1 and B2 is added together is equal to B3. And that's a material balance equations. We just write out balance equations, and notice now we have some mathematical equations that we may need to solve, or we definitely may need to solve for unknowns and so forth, and we'll get into that later as we get into the course a little more, probably in class next time or further in class. But now we have a mathematical framework to analyzing this chemical process. Let me just mention one other thing. Oftentimes when we're writing out our flow diagrams, drawing our flow diagrams, we may just want to label. So I might label this A1, B1, A2, B2, A3, B3, right on the diagram. And that just helps us when we are to better understand the system. So it just lets me know that A1 and B1 are the flow rates going into this stream right here, and A2 and B2 are in this stream, and A3 and B3 in this stream. And again, then we have our equations there. So there you have it. That's the basic concept of material balances and steady state, and we'll get a lot more practice in this course and using these concepts to analyze real chemical systems and to try to get much better detailed analysis of chemical processes.